Okay, Trig, are we ready for this is section 2.2. A little recap of what we did last video. If I'm asked to find theta here, hopefully I would recall that sine and cosine are cofunctions. They're only equal to each other if the angles add up to 90. Okay, so 2 theta plus 50, whatever that is, plus 2 theta minus 20 have to equal 90 degrees so that the cosine of this angle would equal the sine of that angle. So of course we have 4 theta plus 30 equals 90. 4 theta equals 60. So theta should be 15 degrees. Okay, when you see cosine and sine, they're cofunctions. What else are? Secant and cosecant, right? They're the reciprocals of these, and then tangent and cotangent. Another thing we learned were the things about that we learned the reciprocal functions. So to find the exact value of the cosecant of 60, when they say exact, they don't want the decimal approximation that the calculator gives you. I can type in 1 over the sine of 60 degrees. That's what the cosecant is. I'll type that in my calculator, I get a weird decimal. If they say exact, they want you to realize that 60 degrees is one of those special angles that we do have an exact value for. Okay, I know that the sine of 60 degrees is the square root of 3 over 2. Okay, we're going to try to memorize that. You can look at the chart if that helps for a while. 1 over this fraction is, I'm just going to flip it over, right? That's the same as 2 over the square root of 3. That would be fine with me. That's an exact answer. Or if you want a little extra credit, multiply both sides by the square root of, multiply top and bottom, by the square root of 3. You get 2 square roots of 3 over 3. Rationalize the denominator. Give you a little extra credit. Okay, just a little review of some things we've learned. And let's move on. This now is 2.2. I fibbed. All right, we're going to talk about reference angles. Oh my goodness, I'm going to try so hard to explain this because people get these confused. We've learned coterminal angles. Those are different. Coterminal angles are angles whose terminal side lands at the same spot. Here's theta. Here's negative alpha. Both of those are coterminal because their terminal side lands at the same spot. Okay, another coterminal one might be this angle that I go around 3 times and I end up there. Okay, coterminal, we've done that. It's not what we're talking about. We're talking about reference angles. Think about reference. If you need a reference, what that means, something to refer to, right? Okay, so a reference angle. Notice the notation. They're going to put theta prime. It's not the exact angle, but it's the angle that we refer to in order to find its sine, cosine, etc. Okay? The reference angle is different dependent on which quadrant the actual angle is in. Okay? The reference angle is the positive acute angle. Now, when I say positive, I don't mean that I'm drawing it in standard position. Okay, it's just that a reference angle is a positive degree measure or a positive radian measure. We're not going to talk about a reference angle being negative 20. It's the positive acute angle made by the terminal side of the original angle and the x-axis. Okay? If I'm in quadrant 1, I don't have a reference angle. Okay, it's just that angle. I don't have to refer to anything. I'm in quadrant 1, phew, it's just, I can see what angle I'm talking about. I know how to find the sine, cosine, tangent. If I'm in quadrant 2, okay, notice the blue angle, that's theta. To find the sine, cosine, tangent, I'm going to refer to this angle. okay, this measure right here. I know it's not how we usually think of them. They're not in standard position anymore, but whatever this measure is, that's my theta prime. Okay, that's what I'm going to refer to. And the sine, cosine, tangent of whatever this degrees are will be the same as the sine, cosine, tangent of theta. If I'm in the third quadrant, here's my terminal side. The angle that I'm going to refer to is this measure. Again, you go the terminal side to the x-axis. I'm not going over here. Okay, it's the shortest, the smallest distance to the x-axis. Okay, the acute, they said acute angle. This would be obtuse if I went over there. Okay, whatever this degree measure is, positive. I'm just talking about the degree measure, not which direction it's opening, none of that. Just how much is this? It looks like about 45 degrees maybe, I don't know. But that would be what I would refer to for this angle. If I'm in the fourth quadrant, then it's the angle formed here from the terminal side to the initial side, actually, but the short little one, the acute angle. Okay? Those are called reference angles. We use those to help us find the sine, cosine, and tangent of our original angle. Find the reference angle for the following. 134 degrees. I can't find the reference angle without drawing it. I just have to draw it. I don't know why. It just helps me. 134 degrees, that's more than 90, but not, the whole way to 180. I'm just gonna, again, when I say draw, I mean sketch. Okay? 134 degrees, there we go. The reference angle for 134 degrees is right here. I can see it. I have to figure out how much that is. Okay? So let's see, I went 134. I basically want to see how much more to get to go to 180. Right? Here's a multiple choice answer found. I think I pulled this off an SAT test, I think. 180 minus 134 is 46 degrees, correct? Okay. There we go. I'm not sure why 44 and negative 44 are there. 494 is what, a coterminal one? If I add 360. So they were tricking you there if you maybe got confused and thought it was coterminal. Okay, anyway, maybe it's just if you subtracted wrong. I don't know where this 44 comes from, but I pulled that off a test. 46 degrees would be the correct answer. It's just what is this acute angle? Okay, let's find the reference angle for 257 and 316. Take a second. I'm going to draw it. Take your time. Figure out where we are here. Let's see, 257. That would be more than 180, but not down to 270 yet. 257 degrees. I want the reference angle. I can see it. It's however much this is. That's my reference angle. Okay? So what are we going to do there? How are we going to find this part that's there? I went 257, but I want to get back to the 180 mark. So if I subtract 180, I get 77 degrees, I guess there's left, right? 180 plus 77 would give me, what am I, 250? Yeah, it would give me the 257. Okay, 180 plus this 77 degrees would give me the 257. Reference angle for 316 degrees. Well, for 316 degrees, I'm not quite to 360, am I? Okay, there's 316 degrees. And I'm a little short of 360. 360 minus 316 is 44 degrees, right? If I take 316 plus 44, I get my 360. So this is the angle that's left. That's my reference angle. The reference angle is always going to be something less than 90 degrees, right? And then we can find the sine, cosine, tangent of that. That will be the same as the sine, cosine, tangent of 316. That's what we're saying. That's why we're going to refer to that. Okay. Now, here's what people get upset about. They're like, how do you find the reference angle? Sometimes you take the angle and subtract from 180. Sometimes you take the angle and subtract 180. Sometimes you take the angle and subtract from 360. How are we supposed to know which one to do? Okay. You're supposed to know based on where your terminal side is. If your terminal side is in the second quadrant, you subtract the angle from 180. If the terminal side's in the third quadrant, you take 180 and subtract it from your angle, and etc. Okay, so that's why, like I said, I draw it and it reminds me what to do. I don't memorize, okay, in the third quadrant, I take the angle minus 180. I have to draw it, then it reminds me, oh yeah, well, I need this little bit. Okay, understand what you're doing when you find the reference angle and you won't have to memorize. Here's a nice little chart to help you. Okay, when I'm in the second quadrant, I take 180 minus theta. When I'm in the first quadrant, there's nothing to do. It's just the same angle. Third quadrant, I take my angle minus 180. And the fourth quadrant, I take 360 minus my angle. It's what we just did, but this is the, definition. It's in your book, or the instructions on how to find it depending on what quadrant I'm in. All right, so we're going to ask to find the exact value of the sine of negative 870 degrees. Exact value. Okay? If I do it on my calculator, sometimes I'll get the exact value. Sometimes I'll look into it. Like if it ends up being a half, the calculator will give me 0.5 and I'm done. But if it ends up being some square root of 3 over 2 or square root of 3 or something, then it'll give you an irrational number. So you have to, let's just find the exact value the way we're supposed to. Step 1. Step 1, trying to get it, go away. Find coterminal angles until you get one that's between 0 and 360. Okay? So I need to figure out where I am with negative 870, right? I went 360, I went 720, okay, negative in the negative direction. So what I'd like to do is take my negative 870 and just keep adding 360 until I get somewhere between 0 and 360. So I add on my calculator, I just did negative 870 plus 360 plus 360. Okay, and that got me to 210. Okay, so I kept adding until I got to a number between 0 and 360. Then we find the reference angle for that. Okay. So, sorry. Here's negative 870, which was coterminal with 210 degrees. Okay, same side as 210 degrees. I want to find the reference angle now for 210 degrees, which is in the third quadrant. Okay, I need to find that reference angle.